Patterson here. Today we're going to go over Bohr models for physical science. So Niels Bohr is the one that kind of created a model to describe atomic structure and electron configuration. He was able to determine that electrons like to be at certain levels. And so he was able to do a very simple diagram of that. I wanted to state that we really don't agree with this level as of now. So when you get into chemistry, you're going to go more in depth into kind of the different levels that we have currently, our theory. But for right now, this is a very good example of just showing energy levels within an atom. So let's look at these Bohr model levels. So here I have the first ring. Niels Bohr said, hey, I'm only going to be able to hold 2 electrons in this first ring. This first ring cannot hold any more. If I have any more, it has to go to the next ring. So this one can hold no more than 8. So if I have more than 8 in this ring, it can't hold any more. It has to go to the next level. This third will hold a maximum of 18. This will hold a maximum of 32. So let's look at lithium. We got to look at our periodic table. And if you don't remember how to read periodic table squares, I have a video, I'll put it down in the link, and you can go back and watch those. Those will tell you how to find your protons, your neutrons, your electrons, and charges of an atom. So let's look at our square. I see my square. I know this is my atomic number. This tells me how many protons and how many electrons I have. So lithium has 3 electrons. When we do Bohr models, all we're looking at are the electrons. So I know it has 3. I look at my nucleus. This is my nucleus, so my electrons, remember, are on the outside, and I'm going to draw rings. So these rings can be shells, they can be called orbits, they can be called rings. A shell, an orbit, and a ring all mean the same thing. It's an area where electrons are going to hang out. So we know lithium has 3. I know that this first ring can only hold a maximum of 2 electrons. So I'm going to take 2 of these 3 electrons and put them on this ring. That gives me 1 electron left. I cannot put this third electron on this ring. I can only hold 2. So if I have 2, I have to put that third one on this next ring. So that third electron will go here. That's what we call the Bohr model, is this part right here. Now, some people will do what's called a Bohr model shorthand, and I let some of my students do this once they kind of get this down. And this shows you just by writing out, you don't have to do your dots. So I do my circle with my element, so this is lithium. My first ring, how many did I have to put in that first ring? I draw a little half ring, I put in 2. This next one, I put in a 1. So here I have 2, here I have 1, and I'm not drawing out my dots, but I can at least write it out in a number, and that lets me know that you understand how many are going in each level. Here I have aluminum. Take a second, figure out how many electrons does aluminum have. It's got 13. So if I have 13 electrons, how many can I put in that first ring? 2. So I take 2 out of this 13, and that leaves me 11 electrons. What's the maximum number I can have in this second ring? The maximum number I can have is 8. So I'm going to take 8, and then I'm going to pull 8 out of that 11. So how many electrons do I have left? 11 minus 8 is 3. I cannot put those 3 in the second ring because I have it filled now with my 8. So those 3 will go in that outermost level. We also call these in the outermost level what's called a valence electron. We're going to talk about that more here in a second. But this is telling me how many electrons I have in this outermost ring, outermost shell. So Bohr model shorthand. I do my aluminum. I draw out my first ring. And how many did I put in that first ring? 2. I draw my second ring. How many did I put in that second ring? I put in 8. And then how many will go into that third ring? 3. So this is my Bohr model shorthand. Here I have hydrogen. How many electrons does hydrogen have? It just has 1. So this has room for 1 more electron, but all I have is 1 electron, And so this is going to be my Bohr model for hydrogen. If I do a Bohr model shorthand, I will do the letter, I do my ring, and 1. Here I have sodium. I want you to take a second. I want you to draw out your Bohr model. Draw out your dots. So the first one's going to take 2 because I can have 2 in that first ring. So that's going to take 2 out of my 11. The next ring will hold 8. Okay, 8 plus 2 is 10. So I have 10 total electrons here. So that gives me 1 electron left, and that's going to go in that outermost shell. If I do Bohr model shorthand, take a second and write that out. I'd have my first ring of 2, second ring of 8, and third ring of 1. So let's look at this. We talk about periods and groups. Periods are going to be the numbers of rings. What is another name I could use besides rings? I could use shells. I could use orbits. That means the same thing. Period means number of rings. So everybody in this period, a period goes from left to right. And to help people remember, I just say you write a sentence from left to right and you end it with a period. So I'm going from left to right and I end it with a period. So periods go like a sentence. They go from this way. So everybody in this period is going to have 1 ring. Everybody in this period will have 2. Everybody in this period will have 3. Everybody in this one will have 4. So everybody here will have 4 rings. When we talk about groups, these are number of valence electrons. Do you remember what we said valence electrons were? These were the electrons in that last shell, that last ring. So the number of those is your valence electrons. I have a group goes up and down. So these columns tell me my group. This number is telling me how many valence electrons. Group 1 has 1 valence electron. Everybody will have 1 electron in that outermost shell. Group 2, everybody here will have 2 electrons in that outermost shell. We look at this group right here. These are transitions, and these kind of go by a different rule. We really don't work with groups 3 through 12 in physical science. We talk about them, but we don't talk about their rule. They go by something else. So over here, see boron is in group 13 to 18. We work with this group quite a bit too. The thing with this group is they do not have 13 valence electrons. So sometimes you'll see it as 13, 14, 15, 16, 17, 18. And I tell my students, when you see this, you just drop that 1. This group has 3 valence electrons. This group has 4 valence electrons. 5, 6, 7, and 8. Sometimes you'll see this as 3b, 4b, but this is telling you just take off that 1 if you see it as a 13. These don't have 13 valence electrons. Okay. All right, so kind of get that into your head. This is also a good way to double check that you drew out your Bohr model correctly. So let's go back and look at lithium. Lithium is right here. So it's in period 2. So period 2 means I have 2 rings, and it does. 1, 2. Lithium also says I should have 1 valence electron. 1 electron in its outermost ring. And I do. There's nothing else in this ring but 1. So this is more than likely going to be a properly drawn Bohr model. It's a good way to double check. Here I have aluminum. Aluminum's right here. Aluminum is in period 3. So what does that mean? I should have what? I should have 3 rings. 1, 2, 3. And I do. I have aluminum. How many valence electrons does it have? I come up here and I have 13. Remember what I told you to do if you have 13? Just cover up that 1. So how many valence electrons does aluminum have? It should have 3. 1, 2, 3, and it does. Let's look at hydrogen. Hydrogen is right here. So period 1, I should have 1 ring, and it does. Group 1, I have 1 valence electron, and it does. Helium's good. Sodium is right here. So how many rings should sodium have? What period is sodium in? Sodium's in period 3. So I should have 3 rings, and I do. Sodium is also in group 1. So group 1 means I have 1 valence electron, and I do. Now there is an exception to this rule. Let's look at helium. Helium's right here. Helium has 2 electrons. But how many valence electrons does it say this group has? Everybody in this group should have 8 valence electrons. But how in the world can helium have 8 valence electrons if it only has 2 electrons total? So helium's an exception to this rule. Helium has a full ring. All of these orbits here, we have what's called an octet rule. Octet rule is the rule of 8. When they have 8 valence electrons, they are very happy and they really don't want to share electrons with other people. They have a full, what we call full shell, full orbit. Helium has a full orbit, because remember, how many electrons can I have in the shell? What's the maximum number I can have here? It's 2. So this has a full shell, so helium's happy. So helium has an honorary place in this. Helium acts like these other ones, but it does not have 8, it has 2, because its shell is full. Now, 4th periods, when we do physical science, we don't usually go past this 3rd period when we were talking about Bohr models. Now, we'll talk about other characteristics below, but when we talk Bohr models, we usually don't go past period 3, and this is why. When you look at these levels, remember 2 in the 1st, 8 in the 2nd, 18 in the 3rd. And if I did this rule with potassium, I have 19 electrons, 2 are going to go in this first ring. Then I have 17 left. 8 are going to come out of that and fill up that second ring. So that second ring is full. I have 9 electrons left. Remember, this 3rd ring can hold a maximum of 18. So what students want to draw is this. But if I look at the periods and groups, and this is usually when students start questioning, like, this isn't working with my rule. Here, potassium's in group 4. So potassium should have what? I should have 4 rings. 1, 2, 3, but I only have 3. I need a 4th ring. It also says potassium should have how many valence electrons? I should have 1. This has 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This does not fit my period and group rule. And that's because this 4th ring kind of plays by a different game. So what happens is the first 2 rings do the same thing. I'll put 2 in there, and then I'll have 8, and I'll put 8 in there. But remember when we talked about the octet rule, the rule of 8. They like to have a shell of 8. They're happy with 8. So what happens here, I have 9. So what potassium's going to do, it's going to fill this 3rd ring up with 8. Remember, this can hold a maximum of 18, but that doesn't necessarily mean that it has to fill it all up at once. So this is going to fill it up with 8. It's happy. You're going to bring in another ring, and it's going to fill this one up to 8 if it has enough electrons, and then it can come back in here and fill this 3rd one back up to 18. So potassium is wanting to fill this up with 8. It's happy with this shell being 8. So it doesn't want this 9th electron in here. So it's going to put it in this 4th ring. This 4th group, or this 4th period, this 4th period is going to fill this up with 8. Okay, and then it's going to jump back to this 3rd and finish filling this one up with 18. So this one goes by a different rule. We don't get into it in physical science, but I just like to tell students that this is why potassium, calcium will have 2 on the outside, but I have 4 rings, and it doesn't go exactly the way the rules do for the first 3 periods. Okay? All right, that is Bohr models. If you guys have any questions, you let me know. We'll talk to you later.